Okay, we're going to be working on Unit 2, LT1 Notes, Graphing Systems of Equations. A system is a set of two or more linear equations. The solution to a system is the point, the x and the y, where the two lines cross. There are two types of solutions to a system of linear equations. The first is one solution. So when you have one solution, that's when you have your graph. And on your graph, you have two lines. So let's say I have a line right here and a line right here. Okay, so my one solution is where the blue and the red line meet. That would be one solution. And then you would have numbers, you'd have coordinates, your x and your y, where those two meet. Okay, then there's a type of solution that's called no solution. So no solution on a graph, you have your two lines. First you have a line that might go like this, and then you'll have a line that goes parallel to the first line. Okay, when you see that, that's called a no solution, parallel lines. That means they will never cross. They're going to go on forever and ever, and they're never going to cross. And the last one is infinitely many solutions. So I'll have my graph, and I might have one line on there. And on that line, I'm going to go ahead and graph my other line, and it's going to line up exactly where that first line was. That's called infinitely many solutions, or IMS, meaning it's the exact same line. So when you graph these, you first want to get it into slope-intercept form. And slope-intercept form is that y equals mx plus b. So for step one, if you just want to write y equals mx plus b, you can do that. Okay, so that's your first step. The second step is to graph the first line. Then you're going to graph the second line. Then identify the ordered pair where they intersect. Okay, so if they intersect somewhere, you're going to have an x and you're going to have a y. Okay, if you don't have an x and a y where they don't intersect, then they may be parallel. So if it's parallel, you're just going to write no solution or NS. And if they're the same line, you're going to write IMNS, infinitely many solutions. So let's look at this first one. I have y equals negative x plus 8. Remember that we always start with our b value, and because my b is a positive 8, I'm going to start with my dot on a positive 8. And then from there, we find our slope. My slope on this one says y equals negative x. Well, negative x really is a negative 1. And if there's no number under it, I'm going to put a 1 under it. And that tells me I'm going to go down 1 into the right one. So I'm just going to take where I started on that 8, and I'm going to go down into the right for each one of them. And I'm going to throw that line right in there. Okay, now I'm going to look at my next one, and this one says y equals 4x minus 7. So I'm going to start at negative 7, because that's where my b value is. It's a negative 7. And then I have 4x would be my slope, or 4 over 1. So from that negative 7, I'm going to go up 4 over 1. So I'm going to go 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. See how those dots are lining up, or they're landing on each other? That would be my solution right there. But from that dot, I could try and go up 4. 1, 2, 3. This one I can only go up 3. So I'm just going to stop right there and put my line in there. And now I have to find my solution. So here we're going to find our x, and then we're going to find our y. Remember, we always start going left and right. So when we graph, we go up and down. But when you're finding your solution, you're going left and right. So first I'm going to find my hallway. So I'm at hallway where they meet. I'm at hallway 3. So my first number is going to be a 3. And then I'm going up to up to floor 5. So I'm at 3, 5. That would be my solution. So let's try another one. When I look at this one, I have a positive 5. So I'm going to start with a positive 5. And then I have y equals negative x. Remember, negative x really has that 1 and over 1. And we can go ahead and start graphing these right away because they're both in y equals and y equals. So we don't have to do any work to get them into y equals. So I have y equals negative 1x plus 5. I started on plus 5. Now I'm going to go down 1 into the right one. So I'm just going to do that until I can't go anymore. My graph is full. And if I can't go down into the right, I'm going to go up into the left. And then I'm going to throw that line in like that. And now I'm going to graph my second one. So my second one is y equals negative x minus 4. So I'm going to start on negative 4. And this, if there's no number in front, it's a 1 over 1. So now this one's telling me I'm going to go down 1 because it's a negative 1. And then it's a positive 1 under it. So I'm going to go right in the positive direction. So down 1, right 1. And I'm just going to keep doing that till I'm all the way through. I can also go up 1 into the left 1. And then go ahead and throw your line in. And once you see this, those are parallel lines. So anytime you have parallel lines, they'll never meet. So you can say no solution. And if you look back at your slope, this was a negative 1 over 1. And this was also a negative 1 over 1. When you have the same slope, that means it's going to be a parallel line. So let's look at number 3. So number 1 and number 2 were both y equals and y equals. But when I look at this one, it says 2x minus y equals negative 3. So my 2x minus y, I'm just going to rewrite it over here. 2x minus y equals a negative 3. And I need to get y all by itself in order to graph this. So I'm going to subtract 2x. I'm going to go through this a little bit faster than I normally would, but we've been working on this for a couple weeks here. So the 2's are gone. I still have a negative y. Don't forget to take that negative. Equals negative 2x minus 3. So that looks pretty good. You kind of think you have y by itself, but when I look, because it's a negative y, it's really a negative 1, and we can't have a negative y. So to get rid of that negative 1, I'm going to divide each piece by that negative 1. So those are all out now. So now I'm just left with my y equals. And remember, if we divide it by that negative, that just changes the sign. So anything that was negative will now become positive. So my negative 2x is going to now be a positive 2x, and my minus 3 is now going to be a positive 3. So now I can go ahead with my b value, and I can graph that. So I'm going to start at a positive 3, and then my slope says I'm going to go up 2, and then to the right 1. So I'm going to go up 2 to the right 1, up 2 to the right 1. Okay, I can't go up and to the right, so now I'm going to go down and to the left. So down 2, left 1, down 2, left. Okay, and then throw that line right in there. So now we have our first line graphed. Now we're going to look at our second line. So I have 8x minus 4y equals negative 12. So I need to get y by itself. So I'm going to start with 8x minus 4y equals negative 12. Okay, I got to move my x over. So I'm going to say minus 8x minus 8x. So I have negative 4y equals negative 8x minus 12. Remember, we can't combine our 8 and our 12 because the 8 has an x on it and the 12 does not. I'm going to divide by negative 4, divide by negative 4, divide by negative 4. Y is all by itself now, so y equals negative 8 divided by negative 4 is going to give me a positive 2x, and negative 12 divided by negative 4 is going to give me a plus 3. So I'm going to start at positive 3. Let me get my different color here. So I'm going to start at a positive 3, and it tells me I'm going to go up 2 over 1. So from there, I'm going to go up 2 over 1, up 2 over 1. If I can't go up 2 and over 1, I'm going to go from my original spot down 2 and over 1. You're noticing that each one of these are landing on what's already there. So it's making that exact same line. When that happens, we say infinitely many solutions. So I would just say IMS for this one. And then if you want to take a look at this, I have y equals negative 2x plus 3 and y equals negative 2x plus 3. That's another way to notice that if it's infinitely many solutions. If those two are exactly the same, then you know that it's going to be infinitely many solutions. All right, we're just going to do one more here. We're going to do number 5. Okay, so I skipped number 4, so now we're on to number 5. So I have 4x plus y equals 1. My my y is not by itself, so I'm going to rewrite 4x plus y equals 1. And then I got to solve that, so I'm going to subtract 4x and subtract 4x. So my y is by itself. I have a negative 4x, and that 1 was positive, so I'm going to say plus 1. So now I'm in y equals mx plus b. So I'm going to start at my 1, and that's telling me I'm going to go down 4 over 1. So 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. If I can't go down into the right one, I'm going to go up 4. 1, 2, 3, 4, 1, 2, and I can only go up 3 for that last one, so I'm just going to stop right there, put that line in there. Okay, so now I'm going to look at my next one. My next one says x plus y equals negative 2. So y isn't by itself, so I'm going to rewrite it. Okay, we want to get x by itself. If there's no number in front of x, it's really a 1. So to get x by itself, we got to take the opposite of a positive 1, which is a negative 1. So now I'm just going to subtract negative 1x here and subtract negative 1x here. So those cancel out, and I get y equals negative 1x minus 2. My y is all by itself right now, so I'm going to start at negative 2. So I'm going to put a dot on negative 2. So here's my dot on negative 2. And this is telling me I'm going to go down 1 to the right one. So down 1. Ooh, I think I found my solution already, so I'm going to circle it. But I'm not going to stop there. I'm still going to go down 1 to the right one. And just keep doing that all the way through till you can't go anymore. If you can't go down to the right, I'm going to go up and to the left. And then go ahead and put your line right in there. And now this one does have a solution because we have something that we circled. So I'm going to put that solution. And remember, when we're finding a solution, we always start going in our hallway first. So when I look at that solution, I'm finding that I'm in hallway 1. So my first number is going to be a 1. And then I'm going down to, let's see, 1, 2, 3. And because I'm going down, it's a negative 3. So this would be my solution for that one. All right, now we're going to go ahead and do the word problem. Okay, so it says Monica and Max Gordon each want to buy a scooter. Monica has already saved $25 and plans to save $5 per week until she can buy the scooter. And I'm going to change these numbers just for the sake of the graph. It's hard to graph when our first numbers are 5 and 25 and our next numbers are 8 and 16. There's really no good numbers that they meet at, so I'm going to change these two. So change them on yours. I'm going to change this 16 to a 15 and change that 8 to a 10. Okay, so Monica has already saved $25 and plans to save $5 per week until she can buy the scooter. And Max has $15 and plans to save $10 per week. Okay, so now we're going to answer our questions A, B, and C. A says, write a system of equations to represent the situation, then graph. Okay, so let's start with Monica. I'm going to put Monica in red. And it says that Monica has already saved, so she has $25, and she plans to save $5, and then you have these words per week. When it says per week, that means I need a letter there. So let's just use X for my weeks. So I'm going to start with Y equals, and we're doing Monica. Monica is going to save $5 per week. So 5X plus she has $25. Okay, now let's talk about Max. Max saved $15. he has right now, and he wants to save $10 per week. Okay, so let's set Max up just like we set up Monica. So I'm going to start with y equals, Max is saving $10 per week, so 10x, plus he already has $15. Okay, so we did the first part. The first part says write a system of equations to represent the solution. And then it says graph the system. Well, now we have to go to graphing. I'm going to put my weeks at the bottom and my money, how much money he's saving on the side, or they're saving on the side. My weeks, I'm just going to go by 1 week, 2 week, 3 week, 4 weeks. I'm going to make this a little bit bigger, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just go to 10 for right now. And now I know that they have to have at least, my graph has to go at least to $25 because that's how much Monica has to start with. Okay, so her starting value is going to be 25. Well, when I look at this, we don't really have that many going up and down that if we had to go up like too much past 25, we're going to run out of graphs. So I'm going to change these, and instead of going up by ones on the left-hand side where it's money, I'm going to go up by fives. So I'm going to say 5, 10, 15, 20, 25, 30, 35, 40, 45. And that should be good for right now. Okay? So now we want to graph these. So I'm going to go back to Monica, and I'm red. She started at $25, and she's saving $5 per week. So I'm going to start by putting a dot on 25. Oops, did that work? Nope. Okay, so I'm going to put a little dot on 25. And if I'm saving $5 per week, notice that they're all going up by 1. So I'm going to go up 1, which is really 5. From 25 to the next line is 30. So I went up 5 and then over 1. And then I'm going to go up 5, over 1, up 5, over 1. And just keep doing that. You have a lot of room on this graph, so I don't think you need to use every single one of, you don't have to go all the way up, but just get enough up so you have like a nice line going there. Okay, so that's Monica. And now we got to talk about Max. Max, and I'll scroll out of here quick. Max is saving, he has $15 and he's saving $10 per week. Okay, so 15 is going to be my starting point. So I'm going to start with putting a dot on 15. And because Max is saving $10 per week, Monica, we went up 1 line each time because each one of those represented 5. Well, when Max is saving $10 per week, we have to go up 2 lines. So I'm going to say 5, 10, then over 1. And then go from that dot, 5, 10, over 1. And I see I already have a red dot there, so I'm just going to circle it. And now I'm just going to keep going. 5, 10, over 1, 5, 10, over 1, 5, 10, over 1. Okay, and that looks like a pretty good line, so I'm just going to carry this right on down this way. Okay, so we did everything we needed to do for part A, right? We wrote a system of equations. That means our y equals and y equals, and then we graphed it. So our first step is done. Part B says, in how many weeks will Monica and Max have the same amount of money? Okay, so the first question is asking about weeks. In how many weeks? Well, let's look at, let me highlight it for you here. When we look and we go straight down right here, how many weeks do Monica and Max have the same amount of money? Well, it's on the week 2 line. So for part B, I'm going to say 2 weeks. Okay, and then part C says, how much will each person saved at that time? Well, now we're going to use our other axis, and we're just going to go straight across on our other axis. So now I'm going to go across this way, and it looks like that one's reaching at $35. So how much will they have when they have the same amount? They're going to have $35 after 2 weeks. Okay, that's it for this lesson. So I'm going to go ahead and shut this one down, and then I will, you'll have access to the note sheet and the homework sheet, and also these notes to complete. So go ahead and do those next. Please take the notes if you need to stop and pause it, you're welcome to do that as much as you need to. But if you could have this done before you come back on Monday, you will be right on track where you need to be.